Hi! Welcome to NumPy Tutorial Series. In this video, we will cover basic concepts of NumPy Arrays. We will discuss how NumPy Arrays differ from Python lists and what makes them so popular in data analysis. But before we start, please subscribe to Padgers the Teacher and never miss new educational videos.
So, as these lesson series are about NumPy package, I'm wondering, what's NumPy?
NumPy stands for Numerical Python. This is a package for scientific computing in Python.
Okay, what should I do to use NumPy?
First, you need to install it. Then, in your Jupyter notebook, you need to import NumPy. By convention, it is done this way: import NumPy as NP.
I have heard that NumPy is all about arrays, isn't it?
You're right, and the array object is in NumPy's heart. It stands for n-dimensional array. In beginner's lessons, I only go up to 2 dimensions, just not to confuse you too much, but you should know that NumPy is not limited with 2 dimensions. In this lesson, I will highlight some key features of ND arrays and compare them to Python lists. So let's start. The main reason why NumPy arrays are so widely used is their efficiency. NumPy arrays require less memory than lists do, and operations performed on them are very fast. It's crucial in data analysis and machine learning as a field to scoping with huge amount of data. The second very important feature of arrays is element-wise operations, or vectorized math, which I will explain later.
I guess there should be some cost of this efficiency.
Exactly. These two advantages are achieved by sacrificing flexibility. For example, arrays can only store objects of the same data type and can't have rows or columns of different sizes.
You have mentioned vectorized operations. Can you elaborate on that?
This feature can also be referred as element-wise calculations. Let's compare array and list. There is a Python list in the first example that contains 3 elements, 1, 2, and 3. If we execute multiplication operation on the list object, Python just repeats elements n times, so the result is 1, 2, 3 repeated 3 times.
But that's expected, right?
Yes. Now let's compare it with an array consisting of the same 3 integers, 1, 2, and 3. When we multiply NumPy array, we perform element-wise operation. It means that each array element gets multiplied by 3. Huge difference, isn't it?
Yeah, vectorized operations look useful. You know, I already like NumPy arrays, but let's discuss their drawbacks and see how critical are they.
In order to achieve fast vectorized operations and effective memory consumption, arrays are made homogeneous. It means arrays can only store objects of the same data type. From the syntax point of view, you are still able to mix element types in an array, but under the hood, NumPy converts them all to one common data type.
But what does it mean for me as a developer?
Let's first recall that Python lists can store different data types together. For example, here on the slide we see a list with integer, boolean, string, and float. And when we use type function to retrieve the data type of each element, we get mentioned data types: integer, boolean, string, and float. Now, let's compare this behavior with NumPy arrays. In this example, integer and boolean are stored together in NumPy array.
Wait, but you have just said that arrays cannot do this.
From the syntax point of view, they actually can. However, it turns out that under the hood, NumPy anyway converts all the elements to the same type.
I see. In this example, boolean got converted to integer, where 1 stands for true and 0 for false.
Yes, that's why, in fact, all the elements are of type integer in this array. One more example, very similar to the previous one, except here we also have float object. That's why all elements are converted to the widest type, float. So this is something you should keep in mind. If you try to mix types, NumPy will convert elements to the common data type.
As I see, the same element can be stored in different data types. Can I convert array elements to some particular data type?
Yes, you can. S-type function is what you need. Also pay attention that in this example, assignment operator is essential. Without it, array doesn't change.
Why so?
It's because S-type always creates a new array, a copy of the original data. You can try executing this code without assignment operator, and you will see that original array data type remains integer.
You know, I think the first drawback isn't a big deal. Is there anything else? Any other constraints?
Yes, let's first recall that it's perfectly fine to create a list with rows of different sizes. The first row has 2 elements, 1 and 2, while the second row has 3 elements, 3, 4 and 5. You shouldn't do this in NumPy Arrays though. If you do so, the separate list for each row is what gets created, and it means that you lose many NumPy Array advantages.
Moreover, from deprecation warning I see that this functionality should not be used.
Exactly, so don't do this. As a final tip, I want to show you the error that you will get when forget to import NumPy.
I know. We must first import NumPy.
Well done! However, I think when you start practicing, you might forget imports and get this error sometimes, so it's better for you to know how it looks like. But I'm sure it will become a second nature for you to import NumPy before you start new Jupyter Notebook.
You know, I think I should read some more documentation on NumPy Arrays.
It's a great idea. By the way, sometimes it's useful to know which NumPy version you are using. It can be helpful when you are searching for some documentation, for example. Here is how you do this: np.2_version2_.
Oh, helpful.
That's it for today. As you have seen, arrays have some flexibility drawbacks. However, it's usually not a showstopper.
I think efficiency of NumPy arrays significantly outweighs these minor disadvantages.
I agree with you. In the next lesson, we will discuss shape and size of NumPy arrays. Please subscribe to Badger the Teacher and let me know in comments below what is your experience with Python and which topics are you interested in. See you in the next lesson. Bye!
See you later, alligator!